Do you want to keep the guys on the session?
Do you get free, do you have a little limits on your account, your Azure account?
What do you mean limits?
Do you have any limits? Do you have
no, I don't know. Usually when I create a namespace, I always choose the smallest one. I'm not doing any... Okay. Yeah. Okay. So, thank you for coming to my second session. And so today we are going to discuss how to integrate BizTalk with the service bus. We'll start with a brief introduction of the service bus itself. I don't want to spend too much time on this because yesterday Johan made a very good session on the service bus in general, so I will try to fly a little bit on the first slides because I want to spend more time on the code and with the demo and to let you understand how you can integrate BizTalk Server with the service bus. So the key takeaway for this session is to understand how you can get advantage of the service bus to open your BizTalk Server solutions to third parties and to exchange messages in a secure, reliable, and scalable way with external companies. Okay, and it's you will see that it's not so complicated, and it's something that you can do today. So the Windows Azure AppFabric Service Bus is an internet service bus in the classic sense of the term. So it provides a scalable and highly available connectivity and messages capability. This not only to cloud application, but both to on-premises and cloud applications. In this case, running in the Azure environment. So, as you have seen yesterday during Johan and Michael presentations, that the service bus allows to create and expose a service endpoint in the Azure data center that can be accessed by external clients using many different protocols. So you can also, for example, you can create an anonymous service endpoint that expose a RESTful interface, so that can be called by any, for example, internet device, also a mobile application, for example, or you can use other bindings like the NAT TCP relay binding if you want to establish a connection between two .NET applications which are WCF enabled. Okay. So how it works? As we said, in this context, both the client and the service can reside in the cloud or on-premise, and it works this way. Let me show this figure. So first of all, the service has to acquire a special kind of token with a special kind of claim called listen from the access control service. So it submits a request to the access control service. The access control service checks the credentials presented by your service. That is the part that you have seen yesterday during the demos when you configure the transport client endpoint behavior to use the shared secret credentials that you can copy from the Windows Azure Management Portal. At that point, the service presents itself to the service bus with a subscription request, and the subscription request contains a token, and the token contains the claim that was released by the access control service. The service bus validates the subscription request, okay, and if the subscription is valid, the service opens a so-called rendezvous connection point. At this point, the client can start submitting requests to my service, and once again, as you have seen yesterday, you can configure the service to require the client to authenticate against the service bus or not. So if you say in the configuration of the binding that you want the client to authenticate against the service bus, the client is going through a similar process. So it needs to acquire a token with the send claim this time. At this point, the client will send the message to the rendezvous connection point with the token inside. The service bus validates the token, okay, scraps the token from the document, from the request message, and retransmit the message to your service, or relay your message to the service. So, from an API standpoint, the Windows Azure AppFabric SDK supports the WCF programming model for what regards the relay service or relay messaging. So when you download and install the Service Bus SDK, you can find a utility which is called relay. I don't remember relay configuration. The one that configure the bindings in the machine.conf. I don't remember the name. Anyway, it comes with the SDK comes with a lot of bindings. Basically, as you can see, there is a counterpart for each of the existing bindings. So, for example, for the basic HTTP binding, there is a basic HTTP relay binding, okay, and so forth. With plus 2 additional bindings, the net one-way binding and the net event relay binding, that allows you to establish and to implement one-way communications. Or, for example, the net event relay binding allows you to create a multicast messaging solution. Okay. This was not part of the demo I intended to show you, but just to let you understand, when using, for example, the net event relay binding, you can do things like these. For example, I created a sort of chat. So basically, when you are using the net event binding, you can have multiple applications listening on the same URL, and all of them are receiving a message. So in this case, I had 3 different guys which they open, wow, that's the exception. Let me try again. Anyway, if I say here, for example, ciao, all of them are going to receive this message, okay? Hey, what's up? Okay. So this is a way to implement multicast communications. So if you go and look at the configuration of this application, once again, I didn't want to show this demo, but anyway, I'm here. So Azure multicast sample client. You will see that the configuration is very straightforward. So basically, each of the applications open a service endpoint to receive messages. Okay, you see SP, Paolo Salvatore, blah, 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 chat service. It's using the net event relay binding, okay? And they also open a client endpoint to send messages. Okay? So you can achieve this very, very easily. Okay. So now let's look at how you can get advantage of relay services in a BizTalk application. Indeed, Michael already showed these yesterday, but okay. So in this case, I have a WinForm application sending a request message to a BizTalk application. In this case, I have the WCF custom receive location, which uses the NetTCP relay binding. Okay. So the flow is quite straightforward. The Windows form submits a request to the relay service. The relay service retransmits the message to the BizTalk application. I have an orchestration processing the request and sending back the response. And the response goes through the way down back to the Windows form application through the service bus. So the demo is not really rocket science. So I have here relay. When I click the send, wow, let's try again. Well, first of all, take into account that today I'm using a not very reliable connection, the mobile modem, because for whatever reason, for the rest of the presentation, I'm going to show you topics and queues. Today, topics and queues, the messaging API supports only the NetTCP protocol. Tomorrow we'll support also HTTP. So now it requires a certain port, 9354, to be open on the firewall. And for whatever reason, that port is closed. So I'm using the mobile device. So here, simply I use this Windows Form application. Everything you see here, it's downloadable from the internet. So I will show you that this application in particular is that the code is on MSDN gallery, and there is an article for everything you're going to see today. There is an article on MSDN. So basically, I'm just sending a message and receiving a response. That's it. So if we look at the configuration of the receive location, and once again, Michael already showed how to do this yesterday. But you know, I'm a BizTalk guy. I don't like wizards. I usually do things manually, okay? So I created the receive location manually, so I'm using the WCF custom adapter. When you click the configure button, you have to specify the URL. Once again, as you have seen yesterday, you can go and grab the URL of the service bus gateway from the Windows Azure portal. You add the rest of the URL. You specify binding. In this case, I'm using the NetTCP relay binding. In the security section, it's important to know that you can specify wherever a client needs to authenticate or not against the service bus. In this case, I require the client to authenticate against the service bus. In this section, okay, as always, the service throttling behavior, just because you want to set the maximum concurrent calls. The transport client endpoint behavior, to set the credentials used by the WCF receive location to authenticate against ACS in order to open the service endpoint in the cloud. I want you to notice that with the new version of the SDK, under the transport client endpoint behavior, you can find two elements, the client credential and the token provider. You should use the token provider because the client credentials is deprecated. But basically, they expose the same property. So here you can go and specify the share secret, for example. But in this sample, so this comes from I specify the credential in the client credential. So either ways it works. And in the service registry settings, you can eventually specify a discovery mode because you want to make your service discoverable. If you do like this, then you can see your service as Michael showed yesterday in the. Let me see if I can show you. Here we go. So you can see your service with an atom feed. You can also write code to retrieve the atom feed. That's exactly what I did in this tool that will go public very soon. So there are 3 different sections. One is to administer queues, another one to administer topics, and the last one is to administer relay services. And now if I click refresh, everything goes as expected. I should see also, here we go, the net TCP. And this is my receive location. You can also use this tool to submit messages to a relay service. So you can go here, you can open an XML file, for example, I don't know, and then you can choose one of the bindings here, specify the action method, and submit messages. Cross your fingers. So that's part of the process, okay. And that's okay. So, or you can create, and this is going to be more and more, I'm expecting this to be more and more common in the future, to have customers that want to move part of their systems to the cloud. But when you start a conversation with them, they say, right, okay, it would be great, because, moving application to Azure allows me to save a lot of money in terms of, maintenance of the machines and so forth. But what about my application? Because my application interacts with many backend systems, So how can I make my application to interact with BizTalk or with an host integration service or an LOB application and so forth? So as you have seen yesterday during Michael's and Johan presentations, you can leverage for these to achieve this objective. You can leverage Windows Azure Connect and the service bus. So in this particular case, I have a web role hosting an ASP.NET application. The ASP.NET application invokes the same WCF receive location that you have seen before, but this time through the service bus. So what you can see here, it's just an ASP.NET application running in a compute service, so in a web role on my Azure account. So if I click submit and I cross my finger, and the very first time, as you know, it takes time to create the proxy and the connection endpoint and so forth, but after that it's much more, it's faster, much faster. Okay. If you want to go and have a coffee in the meantime, okay, 9 seconds, but then, it's half a second and so forth. And indeed, most of the time in this case is spared by BizTalk because I didn't properly optimize my BizTalk environment. Anyway. Okay, let's move on. And let's start talking about the new messaging features introduced by the service bus. So yesterday already, Johan provided a very good demo. Today I'm just trying to give you some more information, specific information on queues, topics, and I will let you see how you can use queues and topics in a BizTalk application today. So first of all, queues provide messaging capability that enable a large set of applications to exchange messages in a reliable way. And when I say an heterogeneous class of applications, I mean once again, these applications can run both on-premise or in the cloud. Queues are based on a new messages infrastructure, and messages are stored in SQL Azure today, so they are replicated and they are persisted to a durable store. This is no more true. That is, the queue can be up to 1 gigabyte, but because indeed now in production we support also topics and queues which dimensions is up to 4 or 5 gigabytes. So the message size is 256 kilobyte, but this is not a problem because you can use sessions, you know, to overcome this problem, and you can use sessions to send a large message in chunks to a specific receiver. Okay. Now, as you can see on the slide, in a competing consumer scenario, you can have multiple applications receiving from the same queue. So let's say that you want to want to split a message in chunks, and you want to send this message to one of those consumers, and you want to make sure that all the chunks are received by a specific consumer. In that context, you can use sessions, because when you create a queue or a subscription, you can specify these as a property of that specific entity, and when you are using sessions, the messaging infrastructure makes sure that all the messages sharing the same session ID will be received by the same consumer, even in the presence of multiple consumers receiving from the same queue. Okay. Otherwise, a way to send a large message could be to include in the message just the URL. You could take the large message, put the large message in the Azure storage in a blob, and just send the URL of that blob. Okay. So queues are available through 3 different interfaces. So the messaging API that you have seen yesterday during Johan's presentation, WCF that you will see today, and the REST API. So this means that even non-Microsoft applications can exchange messages through the messaging infrastructure provided by the service bus. So these are the capabilities of queues. So we talked of sessions already. So you can use sessions to make sure to send, to open a flow, let's say, a thread between a publisher and a specific consumer. Then you can use reliable delivery patterns using the pick and lock mechanism that you have seen yesterday. Let me add something on this. You have seen yesterday that when you specify the receive as a receive mode, the pick and lock, okay, and you receive a message, if you call the complete method on the receive message, you basically consume that message and delete it from the queue. If you don't do that, the message will stay in the queue, and when the lock expires, it will become available again to be read by all the other consumers. If you instead call the abandon method explicitly on the message, you immediately release the lock, okay? And the message returns to be available for the other consumers. This is another interesting feature, transactions. You will see in the demo that you can, for example, on the send side, you can send a bunch of messages, and you can include your code within a transaction scope. And doing this way, if at the end you don't commit, you don't close the scope, the messages are not persisted to the queue. And on the receive side, it applies the same. So if you put your receiving code within a transaction scope, but at the end you don't commit the transaction, you don't call the complete method on the transaction scope, the messages will stay in the queue. Okay? So this is good when you are processing multiple messages as a unit of work, but at the end you realize that there was something that went wrong and you want these messages to remain in the queue. Then we have the detection of message duplicates. This is really, really helpful because during these years when I made a lot of architecture and design reviews of BizTalk projects, many times I have seen customers and partners to create their own solution to implement idempotency. That is, if they receive the same message twice or multiple times, they need to have a mechanism, you know, to eliminate duplicates. And they usually implement this creating a custom pipeline component, or when using WCF, they can also create a message inspector, for example, for doing this. So this is provided by default by the messaging infrastructure of the service bus. The only thing you have to do is to enable this feature when you create the queue or the subscription. Another interesting feature is the dead letter facility for messages. So if for whatever reason the message cannot be received, or on a subscription something goes wrong with filter expressions, or you specify a time to leave for a specific message and the message expires, the message doesn't go away, the message goes to the dead letter, and we provide you an API that allows you to go and retrieve messages from the dead letter queue. Last but not least, deferring messages for later processing. That's another very useful feature, and I want to mention two particular scenarios. The first is when you are receiving you have a traffic peak, and you have to privilege the processing of messages with high priority, and then you just want to, you know, put it on a side, you know, the other messages, and then when the peak went away, you want to come back and process the messages with low priority. And the second one is when you have a typical ordered ordered delivery scenario where you have to process a sequence of messages in a proper order, and you receive a message that is out of this order. So you need to put this message on the side and retrieve that when at the right moment. Queues can be used in the following scenarios to establish, of course, an asynchronous, loosely coupled communication between different subjects, different systems. You can also use this pattern to flatten highly variable traffic into a predictable stream, just because every consumer receives messages from the queue at his own pace, at his own rhythm, with its speed. Okay. You can also use queues to distribute the load across multiple worker processes, because once again, in a competing consumer scenario, you can have multiple applications receiving from the same queue. And also to decouple clients and services from a temporal perspective, because you don't need the publisher and the consumer to be live, to be up at the same time. You can, for example, use a queue to accumulate some work during the day, and then you can, I don't know, at night, you can start, for example, a worker role that goes and process all the messages from a certain queue and produce results on another queue, for example. So we already touched these, load leveling, offline batch. Competing consumers, we already said that you can use this approach to load balance the traffic across multiple subjects. Okay, so how the messages are structured in the service bus. So first of all, we provide a class in the messaging API called broker message that can be used to create messages. Now, if you look in the documentation, you will realize that this message class exposes many interesting properties. For example, the message ID that can be used to specify the message ID, and this is used for duplicate detection. There is the session ID that you can use when you are enabling sessions on a queue or a subscription. Another interesting property is the reply to. Let's say that you send a message, you are a client in a request-response scenario, okay, where you have a request queue and the response queue. But you can have multiple client applications, okay? And every client application is using a different response queue, okay? The client can send the address of the response queue to the service using the reply to field. And this is what I do during my demo. You will see this in my demo. And the label for custom use. But what is the most important part of a broker message, you will soon realize this, are the user-defined properties. You can look at the user-defined properties or application-specific properties as the context properties in a BizTalk message. So you can create your own, and then you can use these properties in topics and subscription when you specify a filter expression that is used by a subscription to determine what are the messages to select. Another thing to take into account is the time to leave. There is no enforced maximum lifetime, so you can or cannot specify a termination or expiration time. The lock duration, that's another important thing to take into account. For example, when using transactions, I have seen that if you don't commit a transaction, the message remains in the queue, but it remains locked for whatever reason. Okay, so it's important also that you determine the right lock duration. By default, it's 5 minutes, as far as I remember. So as we have said, you have 3 choices to interact with the service bus messaging. You can use WCF, and in particular a binding called net messaging binding, or you can use the messaging API, or if you are developing an application using non-Microsoft technologies like Ruby, Java, whatever, you can use the HTTP REST interface. So I will go fast on these code samples because you have seen these yesterday during Johan's presentation, but that's okay. So the very first thing you have to do when using the messaging API is to retrieve the credentials, to specify the credentials to authenticate against the service bus. So you have to create a token provider. Then you have to create a service URI for your service. You can use the service bus environment object. To this purpose, you have to specify the scheme, SB, and the namespace. At this point, you can use the namespace manager. The namespace manager, as the name suggests, can be used for all the provisioning and administration operations like creating queues, topics, and so forth. You will see this in the next slide. So you create a queue. At this point, I'm using another object, another factory object called messaging factory that can be used to create a specific client for each entity. So the messaging API provides a queue client, a subscription client, and a topic client. Okay? So I'm using, in this case, the messaging factory to create a queue client, and then I use the queue client to send a broker message. And I want you to know one thing, because this is key. If you see here, this broker message has an empty body. There is no payload, and this is okay. It's perfectly okay because I'm just using the custom properties in this case. So it's perfectly okay if you send a broker message with no payload at all, but you are just using the properties. Like in this case, I'm saying that the property called greeting has a value hello world. Okay. And then to receive, I can just say queue client receive, and that's it. As I said, the namespace manager can be used to create, delete, and see if queues, topics, or subscription actually exist. So as you can see in this slide, this is the typical code that you use when you create a queue. You check if the queue exists, and if not, you create a queue. You can delete the queue, and you can do the same with topics and subscriptions. The messaging factory can be used to create a specific client to send and receive messages to and from queues, topics, and subscriptions. So in this case, I create a token provider. I create the service URL. I create a messaging factory. and then I create the queue client and I send the message. I can, and I prefer it this way, you can also create a generic entity called message sender. When you create a message sender, you can just specify the queue name, but you could also specify a topic name. Okay? So this is agnostic of a specific entity. And you send the message. The effort is exactly the same. Or you can create a subscription. When you create a subscription, you have to specify the name of the topic that the subscription is related to, the name of the subscription, and eventually receive mode. Now, this is a more complicated sample of a broken message. So in this case, I specified that the time to leave is 30 seconds. After that period, the message is considered expired and goes to the dead letter queue. Then I specify reply to. That means I'm sending you this request message. Please send me back the response on this queue. Okay? And I specify a bunch of properties. In the second sample, I create a .NET object, and this time I specify my .NET object as a payload by broker message. Only condition is that your .NET object, in this case the job detail class, must be serializable with the data contract serializer. And finally, in the last sample, you can also specify the payload of your broker message starting from a string. And in this case, you can also use the content type property to specify the type of the content. This is this slide shows the options you have to send messages. We usually suggest to use the asynchronous APIs. So for example, here you create a queue client. In the first sample, you create a queue client and you use the synchronous API. In the second one, you are using the asynchronous API. So you send the message, but you also specify a callback that is called when the send operation completes. Okay. And the last sample, yes, in the last sample, once again, I'm using a generic sender. So instead of saying create a queue client, I'm saying create message sender, and then I use the send method of the message sender. For receiving, we suggest, once again, the second approach, that is to use the asynchronous API. So you, instead of using the receive, you use the begin receive, and you specify a callback, in this case done receiving, which is called when your receive operation completes. This is the pick and lock case. So once again, you receive the message, you make some kind of processing. If your processing is okay, at the end you call the complete method. If something went wrong or you got an exception, you call the abandon. You have to call the abandon. Even if you don't, let me say you don't call the abandon, what happens in this case? The message is not consumed anyway, but it remains locked until the lock expires. Okay, so I just want to show you some demos with this tool that I made, and it will be soon available on somewhere over the internet. I don't know. It's you know why? It's strange. We had a blog. I have a personal blog. My team has a personal blog, but somebody decided in Redmond that from now on, all the Azure stuff needs to end up in the same place. So they said to us, don't use your personal blog, don't use the team blog anymore. So, okay, where should I place my stuff? Okay. Anyway, this is a tool that you can use to do many things. So, for example, you can create a queue. Oh, first of all, you have seen yesterday that you can do this on the management portal, of course. So if you go and on the Azure portal, you have seen that there is a specific section where you can create queues, topics, and subscription. But for what regards subscriptions, you cannot specify rules. So and that's very strange, because if you don't specify rules, I mean, subscriptions are quite useless. Anyway, so I just want to show you that a couple of the features we have seen on the slides. So for example, let's create a queue, okay, and let's call these blah 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 or whatever. And let's say that I require duplicate detection, okay, and I can specify other things like lock duration, like I don't know, say 5 seconds, and so forth. I click the create button. At this point, I can go and test the queue. I can, you know, load a file. I can specify a message. And in this section, you can specify your own user-defined properties. Okay. In here, you can specify lots of things for the send side. So, for example, you can specify how many publishers you want to simulate, how many messages you want to send. And on the receive side, it's the same story. Okay, how many consumers you want to simulate, and then you have a graph part. But you know, so for example, here I can say I want to send 10 messages, enable the graph, something like this, and I want to consume those messages. Okay, so I can say start, cross my finger, and here we go. Okay. But you can also use this tool to simulate many conditions. So for example, let's say that I want to send a single message, but this time I don't want to use a different message ID for each message. So I send my message, my receiver received this message. You see message count equal 1, receiver 0. Now if I click again and submit another message, this time, I'm not receiving any message because I'm using the duplicate detection mechanism that realize that the second message has the same message ID, and so eliminate that for you. Another interesting thing that I want you to see is the use of transactions. I'll show you these on the send side. Let's say I'm sending 3 messages. I enable the transactions, but I don't commit the transaction at the end. So, as expected, now wait a second. Okay, let me try again. Wow.
Message ID.
Oh, sorry there. Yeah, of course. Okay, so I sent 3 different messages, but I aborted the transaction at the end, and the message receiver didn't receive anything. Okay, because they didn't got persisted. And on the send side, I want to show you these as well. So I'm not using transaction on the send side, but I'm using transaction on the receive side, and I say I don't want to commit the transaction at the end. So if I say start, okay, so I receive the messages. But at the end I aborted the transaction. So to show you that the messages are still there, I disable the sender and I rerun just the receiver. So if I click start, the messages should be there. Here we go. And this time I consume the messages, okay? So if I click again, the message, well, sorry, I have, if I have to commit a transaction. So if I commit a transaction, I consume the messages. So, for example, now if I re-click, messages are not there. Okay, are gone. Okay, so let's move on because we have just 15 minutes. I have many other things to cover. And yeah, okay. So WCF experience, you will see this in a minute. So basically, you can use WCF to exchange messages instead of using the messaging API. The topics provide publish-subscribe capabilities. So a topic is a sequential message store exactly like a queue, and you can consider each subscription like a virtual queue where you can define rules which determine which messages to select. So subscription can have filters, and you can use topics for message distribution based on rules, like exactly like in BizTalk when you define a filter expression. And so you can use that for message distribution when you have to send the same message to multiple consumer applications, because remember, on a queue you can have multiple consumers, but only one of them is going to receive and process the message. So if you have to send the same message to multiple applications, you have to use a topic with multiple subscriptions. These are the main scenarios that for topics. So to publish events to many subscribers. Each subscription, exactly like a queue, can be shared by multiple competing consumers. You can also set a secondary subscription where you specify a filter which is always true, just for auditing purposes, so you get all messages going through that topic. You can also use topics and subscription to distribute the workload across partition pools of workers. Let's say you define a property called priority with 3 values, low, medium, and high. You can have 3 different subscriptions and 3 different sets of workers processes these 3 different kind of messages. Okay, let's proceed. As you have seen yesterday, you can define rules and filters. So the rules, they determine which messages to select. And the interesting thing is that each matching rule generates a separate copy of a message. Okay, I just want to show you this because I want this to be absolutely clear. So I'm using my tool. Once again, I created a topic with a single subscription, but this subscription has 2 different rules. In one case, I'm saying the machine name, the first rule says, if machine name equal API, the name of my machine, set the priority to high. The second one says, if the username is equal Paulos, set the priority to medium. So it sets the same property to different values. But this is perfectly fine, because at runtime, if I test the, and I submit a message with both machine name equal happy and username equal Paulos, both rules will be satisfied, and I will have 2 copies of the same message. Okay, so if I go here and I enable the verbose mode so that you can see also the properties, and I send a message, okay, so this is okay, so this is the message that was sent, machine with these properties. The payload is not important. If we scroll down, this is the first copy of the message where the priority is equal high. This was produced by the first rule, and the second copy was produced by the second rule. Okay, so I have 1 message coming in, 2 messages going out of the same subscription. Okay.
So what's the business purpose? Why would you do that? So what's the value of doing this?
I understand that there are some customers that said, okay, I just want one of the 2 to fire. I would like to set a priority on rules and have just one of them because I don't want multiple copies, right? I think that's the reason.
No,
well,
actually, the reason I'm asking this is why would you need this feature that you're presenting here? So the feature of actually being able to set 2 rules where you actually...
Well, there are multiple cases because I specify why. So for example, there is a customer in Italy, a partner that made a solution for chains of stores. Basically, it's a solution that allows a backend, their headquarters, to send notifications to individual stores. In each store, there is a smart client running, and they need to send, for example, notification like the change of price for a specific item. But they don't want to send notification to everyone. So that's why they have to create multiple subscriptions, because they have multiple conditions under which they want to receive a specific message. Like, I don't know, if currency equal euro, that's fine, I want to receive this notification. Or, for example, another condition could be, if I'm located in the European area, I want to receive that. So you could create a single rule, a gigantic rule, or you could set multiple rules under which, okay, you receive that message. of course, if in this case, with this implementation, you receive a message that satisfy multiple rules, you have multiple copies of the message, and maybe this is not the intended behavior. I understand that. So that's why you should put a particular care when defining rules in this context.
Okay, so basically there's no real reason why I would like to have two messages, but that's the feature that's implemented, right?
That's a good question. I honestly, I should come back to the product group and ask why they chose to provide this implementation.
Okay, fine.
I mean, I could tell you that maybe, but I'm thinking out loud. There might be some specific reasons where. Oh, okay. I give you one. So, for example, keep in mind you have seen in my demo that I can also use what is called the filter actions to set the value of specific properties. So maybe when you have an incoming message, you want to create for that message multiple copies for different backend systems, and you want to set a different value for specific properties, which are very specific, for that process, for that backend system. So you could have a receiver that is able to receive that message through the subscription, look at the properties in the context, and based on those properties decide to who send the message, for example, or how to process that copy of the message. Because maybe, yes, it's true, you receive one message, okay, and you could do this on the receive side, on the consumer application, but you can also use this as a sort of rule engine. So, you create multiple copies with different properties. So that might be the idea, I think. Okay. So I'm going to skip this slide, but basically when you create a subscription, you have multiple ways to specify filters. So in this case, SQL filters, ship country equal US. In another subscription, I specify ship country equal Germany. Or you can also use these to specify, probably in the next slide. No, okay. You can use the same thing to specify actions, not in this particular case. Anyway, so I have 10 minutes for my demo. So this is the first demo. In any case, you can go and download the article and the code from MSDN. I will give you the URL at the end. So how it works, I have a Windows Form application that can send messages to BizTalk through a relay service. We have seen this part before, but also through queues and topics. So I can send a request message through a specific request queue that I created in my service bus namespace. I receive this through a WCF receive location. I want to show you this. And in this case, I'm using the net messaging binding. But what my demo is doing, and this is the important thing, I created a message inspector that promotes the properties out of the broker message. So my message inspector is a sort of bridge between the broker message, that is the way the service bus sees messages, and the iBase message, which is the way that pipelines and BizTalk in general look at messages. So basically, this message inspector allows you to decide, first of all, it promotes all the explicit properties of a broker message, like message ID, session ID, reply to, correlation ID, and so forth. But you can also specify which of the user-defined properties you want to promote and which one you want to just write to the context. Okay? So this way, the client application knows only broker messages. And the BizTalk application, of course, doesn't need to process broker messages. Okay? And I'm doing the same on the way out. On the CN port, I can use the same message inspector to do the opposite. I want to take some context properties, and I want to include them in the broker message. Okay? In the second demo, it's even more interesting because in this case, I don't have any static port to send back the reply message. I'm just using a dynamic send port. So how can I do that? Because in here, I have an orchestration using a dynamic send port where I configure everything by code. So I'm configuring the net messaging binding, and I'm configuring the address of the destination, because I can read that from the reply to context property. So it works this way. The client application specifies the name of a response queue or a response topic in the reply to field of the broker message. The message inspector transforms that property into a context property. The orchestration reads that property and set that value as the address of the dynamic send port. Okay, so let me show you the configuration. So this is the configuration of the receive location that I use to receive from a queue. In particular, the queue is this one, the request queue. Okay, so I enable batch operation, dead lettering, blah, blah, blah. You can create these also on the Windows Azure portal, of course. You don't need my tool. So here I specify the URL exactly as for a relay service, but here I'm using the net messaging binding. Okay, the net messaging binding doesn't expose many properties. On the behavior section, once again, you have to specify the transport client endpoint behavior and specify the issuer secret to authenticate against the service bus. Here it comes my message inspector. So basically I say these are the properties to promote. So I want to promote the method property, and I want to show you that on the user interface here I have the method property, but this is a user-defined property on the broker message, okay? And I want to show you that I'm using that property in the filter expression used by my orchestration, because this is a direct bound orchestration and is using this filter expression based on this property. Okay. And in the properties to write, I specify another bunch of properties like machine name, username, country, city. Here I have to specify the related namespace. Of course, these are all defined in a property schema, okay? And that's fine. Now, I just want to mention, and I'm not going through the full explanation, you can find it in the article. When receiving from a subscription, you need to also use a custom component like this, because you have to specify different listen URI. So when you expose a WCF service, indeed there are two different addresses. There is the address and there is the listen URI. In general, the listen URI and the address are equal. But in this case, when received from the subscription, they are different. So you have to specify here the address of the topic, not of the subscription, otherwise it's not going to work. And you have to use my component to set the listen URI of the subscription, which is different. And I created this component just because the WCF custom adapter doesn't expose any UI to set the listen URI. Okay. Okay, on the send side, I just want to show you the send port to send to the response queue. This is the first demo. In the second demo, once again, I'm using a dynamic send port. I'm using the same binding, and the behavior section, once again, I'm using the transport client endpoint behavior, and I'm using my custom endpoint behavior. In the properties to send, I specify which of the context properties contained in the response message I want to be included as the user-defined properties in the broker message. Okay, so I just want to show you this. In particular, the application is really generated by my application, while the country and city are indeed the same. They are copied from the request message. So I don't have the time to go through all the possible, cases, because here you can say I want to send through a queue and receive through a queue or a topic and blah, blah, blah. Or here I can specify which of the orchestrations I want to invoke, the dynamic semport or the static semport. Just want to show you this. This is the most complicated one, where I send to a topic and I receive from a subscription and I'm using the dynamic semport. So if I click send, and when you can open the debug view to see what's going on eventually. And I should receive, here we go, I receive a response. Now, this is the interesting thing. Okay, so this is the message ID. How can I correlate the message, the response message to the right request? You can see the correlation ID is equal to the message ID, because my orchestration set takes the message ID of the request message and copies that in the correlation ID of the response. The other interesting thing are, for example, let me scroll down, the properties. You can see these properties was initially a context property within my BizTalk application. It was not promoted, it was turned into a user-defined property by my message inspector. And the other ones are just copied from the request message. So I just send back to the requester, okay? So I finished. Just want to show you one thing. In dynamic semport, when I create the message, in the dynamic semport orchestration, sorry, I can configure everything on the fly. So, for example, I can configure the context properties. So I have a property schema where I define all the context properties exposed by the broker message, like application message ID, correlation session ID, okay? And then I'm using the usual properties exposed by the WCF adapter, like the binding type. You see net messaging binding, and then I call some an helper component to get the binding configuration, the endpoint behavior configuration. That's the interesting part. I set the address of the dynamic semport to the reply to field, reply to property of the request message. And finally, I set the transporter to the WCF custom, okay? So you can find everything. So you can download the code from MSDN gallery, and hopefully you can also read everything from MSDN. So there is a long article, but it's very long. It's not properly formatted yet. I really struggle with the MSDNT, but there is no color. But anyway, it's not important that everything is in there. So there is the full explanation in the crucial detail. And at the end, the important part is also go through the process of creating samples and receive location step by step. Okay, so I want to thank you for attending this session, and I really encourage you to download the SDK of the service bus and start using it. Good luck.
Thank you, Pablo. This is more gifts.
Thank you.
Take care.